grab a picture here, and you can So here's a sketch or a graph of the tangent function, and we'll talk about what we're seeing here as we go along, and then we'll talk about how to graph these. So a couple of important things about the tangent function. Tangent function The tangent function is odd. And by odd, an odd function is symmetric about the origin. So here's my origin, 0, 0. So odd means symmetric about the origin. Tangent function is odd. The period of a tangent function is pi. Period of tangent function is pi. So we can see that every pi units here, my graph is repeating. I'm here at 0 at 0, 0, and I'm at 0 again at x equals pi. So my graph repeats every pi units. Because the tangent of a function or the tangent of a number is the sine of that number over the cosine of the number. That's how one way we define the tangent. The function is going to have an asymptote, a vertical asymptote, everywhere that the cosine of our number is 0. Because anytime we have cosine equal to 0, cosine of our number equal to 0, we'd be dividing by 0, and that gives us an undefined value. So everywhere that cosine of our number is 0, we have a vertical asymptote. And the cosine of a number equals 0. At x equals pi over 2, or we can add any multiple of pi to that number. So the way we write that is pi over 2 plus n pi. So the cosine is 0 at 0 and at pi and at 0. So every time we go halfway around our circle, the cosine of our number is 0. So we're halfway around the circle is pi units. So if we go pi units around our circle, we get back to the same value of cosine. And so we're going to say cosine is 0 when x is pi over 2 plus n pi, where n is an integer.
So what's the other one? What would
So we'd have pi over 2. Pi over 2 plus pi is 3 pi over 2, and then we add another pi. 3 pi over 2 plus pi over 2 is 5 pi over 2. So at any of those values of x, we would have a vertical asymptote. And we'd also have, here we have one at negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. So we can go either direction and keep adding pi over 2 to that to get our next asymptote. So these are the important things about the tangent function. It's odd, symmetric about the origin, its period is pi, and it has a vertical asymptote at pi over 2 plus any multiple of pi. And our graph of our tangent function looks like this. So this is an example. And this is at, my asymptote here is at pi over 2. This is pi over 2, and this is negative pi over 2. And then we have asymptotes, they're just not drawn in here. Every pi over 2 units, we would have another asymptote. Now to graph a tangent function, if we have some specific tangent function. So let's talk about our rules for graphing. They're quite a bit easier than the others. So to graph, we're going to graph y equals d plus a tangent bx minus c, just like we've been doing with sine and cosine and cotangent and cosecant. When we have our function written like this, d is our vertical shift. So d is going to shift the tangent function up or down. A, because the tangent function works the way it doesn't really have an amplitude because it has the vertical asymptotes. A tells us the vertical stretch or compression. So A is just going to stretch our graph out or compress our graph. Our period is pi over b. So rather than 2 pi over b, because the period of the tangent function is pi, our period is going to be pi over b. And our horizontal shift, just like our other functions, is c over b units. We factor out the b to figure out our horizontal shift. So this is what this information tells us about our graph. Now graphing tangent is quite a bit easier. Graphing tangent function is quite a bit easier than graphing sine and cosine. To graph these, we find 2 successive asymptotes. And to do that, we solve successive. Did I put too many S's? I don't think it has 2 S's. S-U-C-C-E, S-I-V-E. 2 successive, one after the next. 2 successive asymptotes. And we do that by solving bx minus c, this thing that's in the parentheses here. Bx minus c equals minus pi over 2. Solve that for x. And bx minus c equals pi over 2. That's going to give me the x location, the x coordinates of 2 successive asymptotes. So then we can sketch our asymptotes. So we solve these 2 equations. We set whatever we have in parentheses here equal to negative 2 pi and set it equal to, negative pi over 2 and to pi over 2. Solve each of those for x. That's going to tell us where to put 2 successive asymptotes. We sketch those asymptotes. The intercept, the x-intercept is going to be halfway between those 2 asymptotes. So our x-intercept is halfway between the two asymptotes. Let's go back here real quick. So here are my two asymptotes. My intercept, my x-intercept is right in the middle, right halfway between those two asymptotes. So I know where my asymptotes are, I know where my x-intercept is, and now I'm almost done. So I find my two successive asymptotes, I find my successive my x-intercept, and then I plot two additional points. And these two additional points are going to be special points. We're going to pick we're going to pick our additional points halfway between the asymptote and the x-intercept. And the reason I pick those points is if I pick that point halfway between the asymptote and the intercept, we're going to get our function at those points y equals plus or minus a. And that a is this number here. So I find my asymptotes by solving these two equations. I sketch those asymptotes. The x-intercept is halfway between them. And I plot two additional points. And I pick the x values that are halfway between the asymptote and the x-intercept. And at those points, y is going to be plus or minus a. And the plus or minus depends on what my function is. So I'm going to pick those points halfway between the asymptote and the x-intercept. And that will tell me y equals plus or minus a. I can plug that point in here and decide is the function going this way or is the function going down. So let's go back here really quick. So here's at pi over 2, and my x-intercept is at 0 for my tangent function. Halfway between pi over 2 and 0 is pi over 4. And at pi over 4, my y value is 1. And for this function, tangent y equals tangent x, a equals 1. And if I go here to negative pi over 4, my y value is negative 1. And if I plug pi over 4 into my tangent function, the tangent of pi over 4 is 1. The tangent of negative pi over 4 is negative 1. And that's how I check to see if it's positive or negative. And that's how that a value tells us about our stretch. Depending on where that a value is, our tangent function is going to be stretched vertically or stretched horizontally, depending on that a value. So these are all that we have to do to graph our tangent function. If we want to graph additional periods, this would be to graph one period. All we have to do is repeat another asymptote by going over one more period and sketching in between those two asymptotes just the same way we did before. So we just have to put our next asymptote and sketch the function in exactly like we did between the two asymptotes we found here. So this is all we have to do to graph our tangent function. Questions? So let's look at an example of going through this process. So let's graph y equals 2 tangent 2x. So for this function, a equals 2 and b equals 2. So our period, this tells us that our period is pi over 2. Period is pi over b, so the period of this function is pi over 2. I'm going to find my two asymptotes. I'm going to set whatever is in the parentheses here, this whatever I'm taking the tangent of. So I'm saying 2x equals negative 2 pi. That's going to give me, or negative pi over 2, I'm sorry, negative pi over 2 to get one asymptote, and 2x equals pi over 2. This will give me my two successive asymptotes. This tells me I divide both sides by 2, so x equals negative pi over 4. Divide this equation by 2, both sides, x equals pi over 4. So two successive asymptotes at x equals negative pi over 4 and x equals pi over 4. Yes?
2x goes from the 2x after the tangent?
Yes. The two, whatever I'm taking the tangent of, that's what this thing is. Okay? So now I'm ready to start sketching. So here are my axes. I'm going to put one asymptote at negative pi over 4. And one asymptote at pi over 4. So here are my two successive asymptotes. My x-intercept is halfway between there. What's halfway between negative pi over 4 and pi over 4? 0. So my intercept is going to be here. And then I'm going to plot my additional values halfway between the asymptote and the intercept. So what's halfway between pi over 4 and 0? Pi over 8. So I'm going to look here at pi over 8 and at negative pi over 8 for my additional points. So I can plug pi over 8 into my tangent function. I get the tangent of 2 times pi over 8. 2 times pi over 8 is pi over 4. Tangent of pi over 4 is 1 from unit circle. And I multiply that by 2. So here, I'll make some marks on the axis. There's 1, 2, 1, 2. So at pi over 8, I'm right here. Let me do that in blue. I have a point here at positive 2, and a negative pi over 8, I'm going to be down here at negative 2. So my tangent function is going to look like that. And if I wanted to sketch another period, if my problem asked me to sketch two periods, I know my period is pi over 2, so I would go out here an additional pi over 2 units. Pi over 4 plus pi over 2 is three pi over 4. Pi over 2 is 2 pi over 4. So I end up with 3 pi over 4. So I would have another asymptote at 3 pi over 4. I didn't make that quite big enough for my scale here. So I'd have another asymptote here, and I could go through the same process of sketching my function between those two asymptotes. And I would need, if I were being precise, I would find this point that was halfway between, find the point here, and find the point here. And if the problem asks you to sketch two periods, in order to do everything accurately, you would want to find this x location, you would find this x value that's halfway between here, you would find the x value here, you would find the x value here. So you would calculate all of those by just adding the appropriate fractions of pi there. Questions on that example? Graphing tangent functions, little less work than graphing sines and cosine functions. All right, let's look at cotangent. So let me grab a graph here. So there's the graph that we just did, 2 tangent 2x. Our asymptotes at negative pi over 4 and positive pi over 4. We said we'd have another asymptote at 3 pi over 4 here. Our intercept for our second period is pi over 2, and we could continue calculating that out. So this is what it would look like if we graphed multiple periods of that last function. All right, the Geometer Sketchpad doesn't have a cotangent function, so I graphed tangent, or 1 over tangent x, which is the same as the cotangent. So I'm going to grab that one. So now we're going to graph cotangent functions. So the important things about cotangent functions. Cotangent functions are odd. Cotangent functions are odd, so that means they're symmetric about the origin. Their period, yes. Symmetric means if we rotate 180 degrees around the origin, our graph would look the same. So it goes up, basically it goes up on one side of 0, 0, and it goes down on the other side. So if we rotate it around, it would do the same thing. So cotangent functions are odd. Their period is also pi, just like tangent functions. The tangent function is the parent function. The period is pi. And we said that the cotangent, we can write the cotangent of a number is cosine x over sine x. And because this is true, our cotangent function will have an asymptote where the sign of our number, sign of our value is 0. When the sign of our number is 0, we're dividing by 0, and we get an undefined quantity. And so sine of 0 at x equals any multiple of pi, or any integer multiple of pi. So on our unit circle, we're talking about up here at pi over 2, I'm sorry, at 0 and at pi. So we have 0 and pi where our sign is 0. So we go rotate around half the circle, and we get a sign of 0 again. So at any integer multiple of pi, our sign of our number is 0. So we're going to have a vertical asymptote at any multiple of pi. So on this particular graph, we're here at, this is 0, and this x value is pi. So my asymptote goes between, or my graph goes between 0 and pi in this example. And my next asymptote would be at 2 pi, next one after that 3 pi, any multiple of pi. All right, so to graph these functions, to graph cotangent, the rules are almost exactly the same. Just a slight change because of our asymptotes are shifted. But we follow a similar procedure. So to graph cotangent functions. We still find our successive asymptotes, and that we're going to write our general form y equals d plus a cotangent of bx minus c. D still gives us our vertical shift. A gives us our vertical stretch or compression. Our period is still pi over b. And C gives us our horizontal shift. So our period is pi over b. We still want to find our successive asymptotes. And we still use this quantity that's in the parentheses here. We're going to solve bx minus c equals 0. And bx minus c equals pi. So because our asymptotes are multiples of pi, we're going to solve bx minus c equals 0 and bx minus c equals pi for the cotangent. That's going to give me my successive asymptotes. The x-intercept is halfway between these asymptotes. And I'm going to plot additional points. To plot 2 additional points. And the points that we're going to pick, to make it nice, are halfway between the asymptote and the intercept. And at those 2 additional points, we're going to have y equals plus or minus a again. And that will complete our graph. So let's take a look at graphing a cotangent function. We're going to graph the same function, except the same function that we did last time, except rather than tangent, we'll graph cotangent. Any questions on our procedure here? Okay. So our example, we're going to graph y equals to cotangent 2x. So we know that a equals 2. That tells us our vertical stretch or compression. B equals 2. So our period equals pi over b. So our period is pi over 2. We're going to find our asymptotes by solving 2x equals 0 and 2x equals pi. So from this one we get x equals 0, and from this one we get x equals pi over 2. So now we're ready to start sketching. So there are my axes. I have an asymptote at x equals 0. So let's draw that one in. There's my asymptote. And I have an asymptote at x equals pi over 2. My intercept is halfway between the asymptotes. So what's halfway between 0 and pi over 2? Pi over 4. So there is where my graph is going to cross the axis. And then I'm going to plot 2 additional points. What's halfway between 0 and pi over 4? So this would be pi over 8. We're going to plot a point at pi over 8. And what's halfway between pi over 4 and pi over 2? Halfway between? So we're going to go pi over 4. I need to go over, we know we've gone over here by pi over 8 units. So I need to go pi over 4 plus pi over 8. So pi over 4 is 2 pi over 8. So this would be 3 pi over 8. So this point is going to be 3 pi over 8. And this is how we're going to figure out if my graph goes up or down. So we're going to plug in x equals pi over 8 into my function. The cotangent of 2 times pi over 8. We're looking at the cotangent of pi over 4. And from our unit circle, we would see that the cotangent of pi over 4 is 1. And we multiply by 2. So we're up here at x equals 2. And at 3 pi over 8, we're going to be down here at x equals negative 2. So there's my point down here. And my function is going to look like so. Make this point bigger so my graph looks right. So there would be a sketch of one period of this function. And if we needed to graph another period, we would go over by another pi over 2 units. So I'd be over here at pi. My asymptote would be there. My function would be halfway between pi over 2 and pi, which would be 3 pi over 4. And my function would go like so. And to be accurate, I would find, just like I found these 2 points, I would find this point, and know that y equals plus or minus a of x. So there would be my graph of 2 functions of the cotangent function. Now, I want you to look at this graph that we made of cotangent 2x. And we're going to go back and look at this graph we made of 2 tangent 2x. So look at this one. And then look at this one again. What if I put a negative sign in front of this function? What would that do to the graph of my function? If I put a negative 2 here. Flip it over the x-axis, what would it look like then? It would look like the tangent function, right? If I flip this over the x-axis, it would look like the tangent function, except I'd be shifted over by, in this particular case, by pi over 4 units, because my tangent function went through 0. So the cotangent, if we flip it over the x-axis and move it over, it looks exactly like a tangent function. And we could see a similar thing with our sine and our cosine. If we shift a cosine function over, it looks exactly like a sine function. The sine function and the cosine function can be thought of as shifts of each other, and the cotangent and tangent functions can be thought of as reflections of each other with a shift. So kind of an interesting little fact. All right, questions on these graphing problems? Okay. So before I give you your homework, we're going to do a little activity.